Good evening, sir.
Yeah, good evening, sir.
Good evening, Dr.
Yeah. Bhavishri. So all of you see my screen?
Yes, sir.
Yes, sir.
I open yesterday's document.
2504.
256. This one. Yesterday, last topic as part of this.
Parallel process, sir.
HDFS benefits high level you have seen.
Yes, sir.
Yeah. So here Hadoop is super speed means because of the parallel process. How parallel process possible means that is the reason by
Horizontal scaling.
DFS.
DFS.
Distributed file system. To implement any distributed file system, what is fundamentally required? Horizontal scaling.
Horizontal.
Okay. Still any other thing?
No, sir, that was the last.
It was the last. Okay. I open now. Wait. Suppose you take Oracle and DB2 database, SQL server, and Postgre. So these databases mainly used for OLTP.
Yes.
But in above databases, parallel process is not possible. Even though they are clusters. Even though they are clusters, that means supporting like a DFS with horizontal scaling. Parallel process is not possible. Why? That is a question. So what is the reason is, very background I am touching. In databases, where you are storing data, sir? You take Oracle database or DB2 SQL server, take any database. Where you are storing data?
Cluster
No.
or hard disk.
Yes.
You are storing
Data warehouse. Data warehouse.
Suppose I want to keep some 10 employees data. What I do in Oracle, I create a table. Into the table, I store data by using insert statement, right?
Yes, sir.
Okay, that means in DBs, I mean databases, we store data into tables. First we create a table, after that you are inserting data into the table. But table is just a logical structure. So here, structure contains what? Columns, the
Rows.
data types,
Rows.
and constraints.
Constraints.
What are the constraints examples?
Primary key,
Primary key,
foreign key,
etc.
yes,
Okay. Nulls, not nulls, such kind of constraints. Only this structural information is only available in table. Back-end storage of table is a table space. Table space. As per operating system, this table space is a file. This table space is a file. In database terminology, we call it as a table space as per operating, but everything should run on top of operating system. So in operating system terminology, the data unit is file. The type of a file system. In above databases. Is not distributed. That means a normal file system. What is the behavior of the normal file system? What is the behavior of the normal file system?
entire file is stored
Entire
in one.
file data is stored in single machine. Got it? That means one table data, even though you have a cluster in the database, one table data will be available in one system only. Maybe employee data may be available in system 1, sales data might be in system 2, products data might be in system 3, customers data might be in system 4, like that.
So
But
files are divided into blocks.
it's not divided.
Mhm.
Okay. All file data is available in a single machine.
Mhm.
That is the reason when you run a query on a table, the parallel process is not possible. This is the answer. So, but in following databases, parallel process is possible. What are those databases? Teradata.
That's
Next,
vertical.
vertical.
Here in these databases, backend file system. DFS, distributed file system. That's why parallel process is possible. But what is the problem with this? You have a limit.
Limited storage.
1024
There is a
nodes.
limit for
0 to
Unlimited storage is not possible.
max number of nodes. There is a limit for max number of nodes. Okay. So after that, Hadoop came into the picture. So here file system.
Two.
Type DFS.
DFS.
And one more feature. No limit for
Max.
max number of nodes in the cluster. Because of first feature, what is the advantage?
Parallel process.
Unlimited data storage. Because of first feature, parallel process. Because of second feature,
Unlimited storage.
Unlimited storage.
limited data storage. One minute, sir. Let me get the water. Stay on the line. Okay. So based on all this discussion, complete advantages of HDFS we will see. Previously only two benefits you have seen. Now all benefits. First advantage as usual,
Unlimited
limited data storage.
data storage.
Second advantage,
Limits for maximum number of nodes. No limits.
Parallel process.
parallel process. Third advantage,
No limits for maximum number of nodes.
that is for the cluster.
Okay.
Okay, all varieties of data. What are the different varieties of data?
Structured, unstructured.
Structured data,
Structured and unstructured.
structured, unstructured, semi-structured.
opposite unstructured,
Semi-structure and
yes, semi-structured data.
structured data. Structure is
What are the examples for structure? Delimited files. That means comma separator files. Like a CSV, TSV, such tab separator, comma separator like that. Even in Excel also you can organize data into rows and columns form. Even in our database, we have tables. In tables also you are organizing your data into rows and columns form. Okay, all these things are treated as structured. Unstructured data, like raw text, image, audio, video, such kind of things. Semi-structured means
XML,
XML.
JSON.
Yes.
such kind of data formats. There is a fourth advantage. All big data compression formats. Suppose generally in our Windows system, what compression technique you will use? In Windows,
basics are like
we
raw.
are using zip files, right?
Zip.
So zip kind of formats are used for GBs of files only, not for the terabytes or multi-terabyte files. The two zip files are not suitable for distributed file systems. Okay. Suppose your data volume is very big, the two distributed file system, you have special compression formats like RC formats, ORC formats, YAVRO, Parquet. Especially in the industry, most widely, these Parquet file formats are used. Okay, almost 75% data compression.
They're in a real time. How do we understand this?
Yes, in real time, 80% cases you will be working with Parquet. Okay, majorly, most widely we will use that one. So these are the things. Okay. But here, HDFS benefits you will see. All the benefits you have seen. How parallel process is possible? First, we clearly understand. So this is the first fundamental point for your Spark. Hadoop. I'm taking case one. So file one, you have the size is, let's say 1 GB. What is the block size here?
256 MB.
256 MB. So what is the behavior of the DFS? When file one or any file is loaded into Hadoop, file is divided into blocks.
Then blocks are distributed across multiple nodes. of
Here,
the
number of
cluster.
blocks, how many?
4.
1024
4,
MB divided by 1 GB means
1024 MB.
MB divided by
256 MB.
256. Totally
4.
4 blocks.
4 blocks.
This means all the data is being divided into 4, right, sir?
Yes. Block 1, block 2, block 3, block 4. Okay. As
So-
block 1. Yes, please.
Sir, the block size has a limitation or it doesn't have any limitations?
You can, in the beginning of the Hadoop, 64 MB. If you want to increase, you can make it as double, multiples,
Okay.
128 MB. Again, if you want to increase, 64 into 3,
250.
120, 132. So now the starting block size is
56.
256. If you want to increase, multiple, 256 into 2, 512 MB. Again, increase 1012 MB. On that way, you can increase, which can be configurable. And block 4. Okay. So these blocks are distributed across
File system.
multiple nodes. Multiple, which nodes? You have master nodes, slave nodes.
No.
Nodes of the cluster.
That means worker nodes,
Slaves. Okay.
slave nodes.
So the master is also known as node, sir.
Hmm?
The master one.
Master is not storing,
Okay.
but master stores metadata. Okay.
Okay.
So here master node in HDFS, master node is HDFS, that name node. In Hadoop, master node is called name, which holds metadata of all files.
Sir, metadata as in?
Metadata means data about the data. What is the meaning of data about the data?
Data about the file storage,
So,
the file size.
suppose this is your data. Think that is a image. Is a photo. This is data. What about metadata? Like pixel
Pixel.
size. That means resolution. And size of the pic, like 30 by 3, 30 by 30. And Mr. John, who is photographer. And camera is Sony of M33 model. So this is data, this is metadata, which is data about this data. Understand?
Yes, sir. Yes, sir.
Okay, in a table point of view, let's talk about a table, example sake. I have a table, the table name is employee. I have columns ID, name, salary. And I have 100 employees for it. This is data. What is the meaning of metadata here?
It should be ID, name, salary.
Table name. Okay. What columns you have? What is the data type of each column? ID as integer. Name as string, that means varchar. And salary as
Integer.
float.
Float.
Number of rows in this movement, maybe 1000 rows. Okay. Such information is called metadata. This is data. This is metadata. Got it? That means simply which explains you about data. Data about the data. That is called metadata. Let's talk about name node. That means master here. Because how big data clusters are working, this knowledge is important so that you can easily understand about the Spark. Think that I have some 100 nodes. This is a 100 node cluster. 1 minute. Come back to your story. File 1. What is the size?
1 GB.
1 GB. For easy sake, let's say not 1 GB, half GB. Okay. What is the size? Half GB means
I12.
What is the block size?
256.
56 MB.
Number of blocks?
2 blocks.
2 blocks. As block 1?
Block 2.
Think that block 1 stored here. But block 2 is stored here. Okay, block 1 stored in node 1, block 2 stored in. Actual data, suppose here, total to suppose 2000 records. Let's say you have 2000 rows. For rough understanding here, 1 to 1000 rows. Here, 1001 to
2000.
2000 rows. Okay. So the actual data stored in node means slave nodes. This is worker 1, slave 1, slave 2. These slaves are called data nodes. Data node 1. In Hadoop, the technology changes. Data node
2.
2. 3, 4, 5. In this way, let's say you have data node 100. Okay. 100 node cluster total. So this is name node. Name node is
Meta.
master.
Master.
Data nodes are slaves. It holds metadata. What is that metadata? File 1, block 1, stored in which machine?
Data node 1.
Data node 1. Same file, file 1, block 2, stored in which machine?
Data node 2.
Data node 2. Got it. After that, whenever I run a query, for example, this data, F1 contains employee data. I'm running a job. The job, I'm triggering a query. Select sum of
Sum of
salary.
From
from,
employee data.
let's say employee. This query I am submitting. So this query pass it to
Metadata.
master has clarity. What is the backend of the CMP? File one. File one has how many blocks?
2 blocks.
2 blocks. Block one, block two. And addresses of those blocks. Block one available in?
Data no.
Block two available in?
Data no
Okay.
2.
Then, so job is divided into two tasks. Why two tasks?
Time consumes.
5.
Because I have 2 blocks.
Yes.
Because of 2 blocks, the job is divided into 2 tasks. As task 1 and task 2.
2.
Now, task 1 will be assigned to node 1 for block 1 processing. Similarly, task 2 will be assigned to
Node 2
Not
node
for
2,
block 2 processing.
block 2 processing. Both will be executed
Parallel.
parallel, not one after one. At the time node 1 is working with block 1 data, at the same time node 2 is working with block 2 data. Got this?
Sir, for the job you mentioned, like if it is divided into 2 tasks, like what could be like task 1, task 2, sir?
Task 1 is what is our query?
Select some salary from
So
employee
what is the
table.
meaning of what is the expected result by this query?
The total salary.
Total salary of all employees, right?
Yes, sir.
In the block 1, how many employees are there?
1,000 rows,
1000
1,000
employees.
employees.
Task 1 is doing these 1000 employees total salary.
Okay.
Task 2 is doing the 1001 to remaining 2000 to remaining 1000 employees salary.
Mm.
Suppose from the task 1 result is 5 lakhs, from the task 2 result is 6 lakhs. What is the total salary?
11 lakhs.
5 plus 6. Again, the independent results will be collected by other machine.
Okay. Yes,
But
sir.
the final summation will be done.
Okay,
Yes,
sir.
sir.
What is the advantage of this? Speed.
Speed
Speed.
sets all about.
Previously 1 minute is time. Now what is the time?
6,
30 seconds.
30 seconds.
Mm.
I think that this parallelism is done by 100 missions. Still same time, right?
Yes.
Suppose big
Yes, sir.
volume of data distributed into 100 missions. All the 100 missions parallel processing this. Even though big volume of data with high speed, you are achieving the result.
Yes, sir.
So this is what final goal. Correct.
Sir, if there is a group by, how it will be done?
If it is group by, observe this. For our easy understanding, Ravi male 10,000. Rani female 20,000. Venu male 30,000. Veni female 40,000. Krishna 50,000. Abdul 70,000. John 80,000. Rama 90,000. Let's say male, female. It's not Rama, it's a Rama. My query. Select gender. Sum of salary. From EMP. Group by
Gender.
Gender.
This is my query. Here, task one, what it is doing, observe. Separating required elements. To do this, suppose think that I have many fields, but to answer this question, what fields are required to you?
Gender.
Gender, sum of salary.
Gender and salary is enough, right?
Yes.
And it should be grouped by gender.
F, M10, F20, M30, F40. This is temporarily stored somewhere in the node, same node. Locally that will be stored. Same thing, do the same thing for the second node.
M50,
M50.
M70,
M50,
M50,
M70, M80,
M70,
yes, 70.
M80,
M80,
M,
and F90.
90.
F9. This is temporary result. Still I have 100 nodes, right?
Yes.
Yes, sir.
Here, shuffling will happen, data grouping. All males will come into this. What are the male salaries here? From the first node.
M10, 10,000.
10,000.
M30,
30,000.
40,000.
50,000.
Sorry.
and that's it, sir.
50.
50,000.
40 is not there, sir.
There is no problem.
50,
30,
70, and 80.
50,
50,
50, 70, 80.
70, 80.
70, 80.
80,000.
80.
right. That's all the data from these two nodes. Only males are directed to node 3. Similarly, all females are directed to
Node 4.
Node 4.
group it, group them.
40,000 female,
20
20, 40.
20, 40,
90.
and 90.
and 90. This is step 2. In the step 3, aggregation. After aggregation, what is the result? Male 10 plus 30, 40, 40 plus 50, 90.
24,000.
70, 160, 160 plus
Like 40,000.
160 plus 80, how much?
20.
240.
2 lakh.
So that
And from this, what is the result?
1 lakh 50.
20, 40, 60. 60 plus 9,
150.
1 lakh. 50. Again, these two results will be collected and written into your given output file.
390.
Understand?
Yes, sir.
All of you understood this?
Yes, sir.
It doesn't matter
Yes, sir.
if it is a grouping operation or non-grouping operation. Okay? So parallel process proper will be.
So added, it's like male and female they are going to add, sir.
Yeah.
Again, these output are added.
Yeah, again, this output will be stored in given output file. Final result will be stored because all these results are temporary only. This result temporary, this result temporary, this result temporary. Final result is what as per the given query. This is. These two results are collected by one machine and that will be written into HDFS again.
Sir, so generally one master node and the collection of data nodes, So this will be assigned by one for one file, sir.
This output is assigned to one file. But in the backend, you treat it as a file. In the backend, what will be there? Blocks will be there.
Okay.
Got it? Finally, what will be stored in HDFS? Blocks will be stored in HDFS. But you are interacting with those blocks with file name.
Okay, sir.
So whatever it may be, whether it is a grouping or non-grouping operation, you are achieving final high speed. Okay. So in Hadoop, before going to this topic, once again, case 2, I am coming to the case 2. Same file 1. Let's say 512 GB. Block size.
Block size.
256.
It's not 512 GB, it's half GB. Let's say MB. Number of blocks.
2.
2. Block 1 stored in
Node 1.
node 1. Block 2 stored in
Node 2.
Node 2.
think that you have 100 nodes. Okay. During process, task 1 assigned to your job will be divided into 2 tasks. Task 1, this is for
Block 1.
block 2 data. So task 1 is working with block 1. Task 2 is working with block. Executed by? No.
No, data.
Node 1 and node 2, these slave nodes. Okay. Now my problem is during this, if any one of active node is down, did you understand my statement?
Yes, sir.
During this, if any one of active node is down, example, node 2 is down. What will happen? In the node 1, task 1 is running. In the node 2, task 2 is running. So if you got a result, is that result a correct result? I am asking sum of salary. Task 1, my job is divided into task 1, task 2, task 2 assigned to node 1, task 2 assigned to node 2, but node 2 down. Understand? Whatever the result you got in this moment, is that result correct result?
No.
Okay. What will happen here is, if any active node is down, entire job will be terminated. Otherwise, you will get wrong results, right? Entire job. Job means all tasks. You have 100 nodes or 1000 nodes.
Will be
One
terminated.
of the active node is down now. Think that you have 100 tasks. 100 tasks are assigned to 100 missions. All 100 missions are running parallelly. Suddenly, node number 30 down. The entire job has to be terminated. Entire job will be
Terminated.
terminated. Is it good way?
Mm.
No.
No. I have 10 students. One of my student is not coming for the class. Just because of he is not coming to the class, should I cancel entire class?
No.
Not recommended. If I don't come, okay, class is cancelled, that is okay. If one of student is not coming means entire class should be terminated. That is what happening here. That is bad way. Okay, same style Hadoop is behaving here. Now need solution to this problem. We need fault tolerant. Got it? We need that fault tolerance facility. Now, the next question for this. How Hadoop implements fault tolerance. The answer for this, by creating
Copy of the block.
block replicas and distributing replicas across multiple nodes. Can you explain me this meaning?
So this means whenever we have any nodes, any kind of issues,
Okay.
the faults are going on, it is going to create separate blocks with replicas and distribute replicas across the multiple.
It's like duplicate copies.
Yes. Previously, number of blocks, how many?
Number of
Two
blocks. We were having two.
Two. Block 1 into 2. 3 copies. Block 1, copy 1. Block 1, copy 2. Block 1, copy 3. Including original. Now here again, block 2, copy 1. Block 2,
Copy
copy. Block 3, copy 3. So in Hadoop, default number of blocks. Default number of replicas for each block.
Default number of
default number of duplicates.
3. Understand? So
Yes, sir.
previously I have only 2. Now each block is replicated for 3 times. So total number of copies now 3 into 2.
6.
6. Yes. Now let's come to play with this replicas. Come back to the story. Sorry.
with these replicas.
These are nodes. Total our cluster is very bigger. 100 nodes. Think that you have 100 nodes. Block 1, copy 1. Block 2, copy 1. Block 2, copy 2. Block 1, copy 2. Block 1, copy 3. Block 2, copy 3. What about metadata?
Name node.
What about metadata? File 1,
File. Block
block
1.
1, copy 1 is stored in
Node 1.
data node. Same thing. File 1, block 1, copy 2, stored in
DN2.
No.
Data node 2.
Data node 4.
no
4.
data node 4. Who will decide which block, which copy to be stored in which machine? Who will decide?
Name node.
Master, yes, name.
Master.
Next, file 1, block 1, copy 3, stored in
Data node 5.
data node 5. File 1, block 1, sorry, block 2,
Block.
copy 1,
Data node 2.
2. Same style, file 1, block 2, copy 2,
Data node 3.
3.
data node 3. File 1, block 2, copy 3,
Data
Data
node
node
6.
data node 6. Now master has clarity, right? Which block, which copy available in which node. Every information is available with master. Now you are submitting a job. How many tasks now?
2 tasks.
2 tasks or 6 tasks?
6 tasks.
6
No.
tasks.
No. 2
2
tasks.
tasks. Yes.
Number of tasks is equal to number of unique blocks.
Yeah.
Even though block 1 for 3 times, block 2 for 3 times, uniqueness is only 2, right?
Yes, sir.
That means 2 tasks. Think that task 1, this is for block 1. Assigned to block 1 available in which missions?
Node 1, node 4, node 5.
Node 1, node 4, node 5.
5.
Okay, think that assigned to DN, that means node 4. Who will decide it? That is not under control, that is under
Master.
control of master. In this moment, which mission is immediately available, which mission is having less burden, to that mission, master will assign the work. Okay, so think that task
Yes, sir.
1 is assigned to this mission. Similarly, task 2. This is for suppose block 2. Think that this is assigned to node 2. Now what happens? These 2 missions are running
Yes.
parallel.
Parallel.
Actually, I have 100 nodes, but active nodes are only 2. Here, active node means currently which node is processing the data, that mission is called active node.
Active.
Understood? So task 2 by node 2, task 1 by node 4. These 2 missions are running parallelly. Now problem statement. Suddenly, node 4 is down. Previously, what happened when there are no replicas?
Entire data were
Yes, entire
terminated.
job terminated, right?
Yes, sir.
Entire job got terminated. Now nothing
But
happens.
in
Master
Task tolerance.
terminates, already terminated. Okay.
master terminates.
Reassign. Reassign the task 1. Because node 1, node 4 failed means task 1 terminated, right?
Yes, sir.
Task 1 to other
Node 2.
available
Nodes.
nodes in which task 1 is processing with which block?
Block 1.
Block 1, in which block 1 replicas are available. Okay. Task reassign the task 1 to any one of available nodes in which block 1 replicas are available. In which missions block 1 replicas are available?
Node 1.
Node 1
Node
and
5.
also
Node
Node
4
5.
also.
node
Node
5.
5.
4 is down now.
In this
5,
moment,
5.
it is immediately available to that
5.
mission. Master will assign. As example, task 1 assigned to
Node 5.
node 5. So that job execution will be continued or terminated?
Continued.
Continued.
Even though one of the node is down, nothing happens to the job. So job execution continues. Understood? This is the way the fault tolerance is possible. So based on this explanation, whenever job will be terminated,
Sir, but
whenever job will be terminated,
When node
When
is
no
down.
machines are available.
that means when no mission is available, block 1 is available in 3 missions. Node 1, node 4, node 5. If these 3 missions are down at a time, understand?
Can you
No, sir,
explain once again, sir?
Suppose block 1 data. Block 1 available in 3 missions, right?
yes.
Yes, sir.
Node 1, node 4,
Node
node
5.
Node 5.
Node 1, 4, 5 at a time down. At a time, when I have only 3 replicas here, at a time, all these 3 nodes down, then job will be terminated. But what is the probability all the 3 missions will be down at a time? Very less probability.
Very less.
Okay.
Yes.
Suppose, as per your past executions, you identified most of the cases 3 or 4 missions downing at a time. Then increase the number of replicas in the configurations. So finally, in this discussion, what is the advantage of replicas?
Termination, it's not
Even
important.
though one active node down, still your copy available in another node, so that job execution
Yes.
can be continued.
Continued.
We have duplicate copies of all these.
Got it? That means final advantage, you are achieving a fault tolerance, right?
Yes.
Yes, sir.
This is called resilience.
Resilience.
Okay, resilience.
This is called as resilience.
Understood. But what is the problem with this?
Problem, sir?
Extra space. It is occupying more space or not?
It is, sir.
Yes,
Because
sir.
of
It's
replica.
occupying.
Storage cost. Because of replicas, 3 times storage extra cost, right?
Yes, sir.
That is, of course, you want to achieve fault tolerance means definitely have to compromise about the storage cost. Understand?
Yes.
Storage cost is more.
Once the node is down, this block will be immediately copied to the other node.
Yes, that is later there is another process called reorg process will be there. During that reorg process, another block of this copy will be again recreated in another machine.
Okay.
Okay. So finally, at any cost, your data is safe.
Yes, sir.
Yes.
And also during the execution, your job will not be terminated because of one node is down, one or few nodes down. Still, your job execution will be continued. So in this entire explanation, the greatness of Hadoop is there is no developer or user or admin involvement. This entire fault
In Hadoop, you're saying.
yeah, in entire the Hadoop, this entire fault tolerance is done automatically by the master.
Oh,
There is no admin involvement in this process.
Automatically done by
Got it?
it's done automatically.
Automatically.
masters.
Okay. So in this way, like this thing. But finally,
No admin is involved, sir.
admin is involving when
When you create
add the
master.
nodes. To add the nodes, okay, to remove the nodes, to set security for the nodes, for the data, for the users, for such kind of activities will be done by the administrator, not for the fault tolerance. Okay, fault tolerance is a default behavior in the Hadoop. Okay, but the problem
In fault tolerance.
with Hadoop. Need to set up own infra. That is physical clusters. That means you need to maintain biggest
Physical cluster.
data center. Too much cost. Got it. Suppose 1 petabyte of data daily you want to maintain. Minimum to minimum 4,000 or 5,000 node cluster you need to maintain. Lot of infrastructure cost, a lot of load balancers, lot of networking components are required. That too monthly maintenance cost is too high. Okay. That's why to avoid infra cost, and the maintenance cost, cloud file systems introduced. Similar to HDFS. What are those? GCP has Google Cloud Platform, has GCS, Google Cloud Storage. AWS has S3. Azure Data Lake, you are in Azure. What is your storage?
Gen 2.
Azure Data Lake.
Gen 2.
Gen 2. All these are similar to HD. But hey, what is the difference? HDFS is on premises, whereas these file systems on cloud. No need to set up the infra. Understand? But all these are cloud distributed file systems only. All these things have copied the feature from HDFS. Got it? Like this. So later about the cloud file systems, so we will see. Up to now, about the storage and the fault tolerance, all these things we have discussed. But already yesterday we discussed about like Hadoop services. Hadoop has two services, right? One is storage. Second one?
Process.
Storage different.
Process.
Process different. Now latest. HDFS no change. Old
Map reduce.
map reduce. After that,
Test.
page. After that,
Spark.
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 this is
New.
2015. Understand?
Spark.
So this is Spark. Simply, this is what our exact goal. What is Spark? Now give me a small comment.
Execution. Data process execution.
Execution.
Execution machine.
Then execution engine.
Machine.
Two
Engine.
features. Try to recall yesterday.
Memory computer. In memory computer, and massive parallel process.
In-memory computing. Second,
MPP.
Parallel
Massive parallel process.
MPP.
MPP.
Massive. Parallel.
Process.
Got it. So up to now I have discussed about PP. Now you are talking about
massive.
MPP. Okay, first we
MPP.
discuss something about in-memory. Then we do what exactly the parallel process and what is massive parallel process we will discuss. Okay. So let's meet in tomorrow's session.
Okay.
Cell process. Yes.
Wait, I will save this. Already this document is shared with you. Once again, I load it.
Hello, sir.
Yes, madam.
I do have a little doubt.
Yeah, please.
Sir, in hello,
Please tell me.
sir, when there is a process of duplicate or replica creating, can we assign next task to the other nodes? Yeah, we have to wait until the first replica or the task we have to complete. Can we assign them a different task also?
You don't have any control over that. Only master is taking care of that.
Yeah, master is gonna decide. Wait.
There is no control over this work assignment, task assignment. Suppose node 4 down, still your block is available in node 1 and node 5. Any one mission master will decide. Okay, suppose master selected node 5. The running task 1 will be assigned to node 5. This is already terminated. Okay.
One node only assign one task, or maybe having different tasks also.
No, same task. Whatever the previous task running in node number 4, the same task is reassigned to node 5. Because task 1 is meant for block 1 data. Block 1 is available in node 5. That's
Sir,
why.
if we have 100 tasks and we have to create replicas for 100 tasks, then there may be
You are
300.
not creating replicas for the tasks. You are creating replicas for, okay, 100 blocks you have means if each block replicated 3 times means how many blocks? 300 blocks. That means 300 copies. But number of unique blocks are only 100. So that number of tasks, how many? Task 1 to task 100. This is for block 1. This is for block
100.